Welcome back. Let's talk about databases, but I'm going to give you a heads up. As a web developer, you might not actually work too much with databases, especially when it comes to scaling and improving their performance. However, we can take a look at databases from a higher level so that we can connect the pieces, and if it ever comes down to it, we can structure our applications so that it takes advantage of however the database is set up. So let's take a high-level overview of what we can do with databases. I have listed here 6 items that are the main ways that databases can scale. And the very first one is probably the most important one that you should look at before you do any sort of optimizations on a database. And that is to identify inefficient queries. Before you start looking at your database and how you can scale it, throwing more money to improve it, you first have to ask yourself, am I using the database efficiently? Am I making SQL statements to the database from my, let's say, API server? Am I making these requests in an efficient way possible? And there's many ways that you can improve that. Not having too many joins or asking for too much information when you only need a little bit of information. There's many ways that you can improve your SQL queries. But the 2 main things that you can improve on is making sure that you only request what you absolutely need on your server. And then finally, using things like indexes to improve this querying of data. Now, what are indexes? Well, usually data access in a database is done with blocks on disks. That is, when we query a database or a table, we have to access that entire disk block with that information of the table. And usually this data, let's say I have username and age, is not sorted. So if I was searching for a user that is 34 years old, well, that's going to require me to look through the entire table. Whereas if that data was sorted, I could do something called binary search, which makes it a lot faster for me to find that user. So there's a huge performance increase by doing what we call indexing. So keep that in mind. Indexing is a way of sorting a number of records on multiple fields. So if I create an index on a field that is age of the users table, it creates a new copy of that data structure, which holds the field value and a pointer to the record that it relates to. So think of it as creating another file on your computer. Instead of having just the users table file now, you also have a users index file. But next time we query any user age questions, we can just use that index file to immediately find that user, allowing us to use binary searches again to really increase performance. Now, the obvious downside to indexing is that these indexes require additional space on disk. Again, we're making another file. And depending on your system, having more and more space might, especially if the database is large, might not work out well. All right, so all this index talk and inefficient queries, how can I actually create an index? Well, remember our SQL statements. To create a table, we did the create table command, and then we gave it the table name. To create an index, we simply say create index. We can have an index name, let's say user age, on the table name, in our case, user, and the column name, age. And that's it. After we do that, anytime we query our users table for something like age, we have way faster query. Again, when it comes to efficient SQL commands, that's something that usually you have a database team or database engineers for. But creating simple things like indexes or making sure that you're only requesting what you require from the application is the way to do it. Remember, storage is the slowest piece in a relational database. One bad SQL query can cause a huge amount of delay. All right, so the next topic is increasing memory. And this is a nice, simple one. If you have a bottleneck that is your storage, your first course of action, usually after you've looked at inefficient queries, is to give it additional memory. And you do that by improving the hardware that the database is working on. By increasing the amount of information in memory, you aren't accessing the disk as often as you increase your speed, so that you can store more information in memory for a database. But as with anything, when it comes to memory, you can only add a certain amount. You won't be able to add the entire database in memory. Let's talk about the next one, and that is vertical scaling. And this is usually done with something like Redis or Memcached. And Redis is something that we're familiar with and we've talked about. Vertical scaling can also include increasing memory, but in this case, we're talking about adding another service so that your system effectively uses the resources better. So adding a system like Redis is kind of like adding memory, but not doing it on the same server as we would have in the first case. So by adding another server that has Redis, that is a memory storage, which again, we know that makes things fast, means that we've just increased the memory of our database. But how does that help us? Well, for example, if we ask a query, like a user's age, and we keep noticing that this query of asking for the user's age always happens and every user uses it. Well, we can actually cache that response. Again, something that we'll talk about, but we'll say, hey, before you even ask me about the user's age, check Redis, which is in memory, is a lot faster than I am. Check if Mr. Redis or Mrs. Redis has that information. If it does, well, just return it. Otherwise, pass that information on to me and I'll give it back to you. But when I return that user age, I'm actually going to go through Redis, and if Redis doesn't have it already, I'm just going to store it there before I send it over. So it's kind of similar to CDNs if you think about it. Again, we're just caching things that are often requested so that we use memory access instead of disk access. Another option for databases is something called sharding. And I want to warn you, sharding is one of those things that sounds like it makes sense, but it's extremely hard to do. And it's a very tough problem that raises a lot of issues that you most likely won't ever implement yourself. But sharding, as this animation just demonstrated, is simply breaking down the website into different pieces. When you start having more and more storage in the database, it gets too big to handle. So you break up the data, maybe by users that are younger than 30 and users that are older than 30. So that when you make a query, instead of searching through that entire list of users, if we know the user is 23, we can just request to query this database instead of this one. Another thing we can do is adding more databases to the problem. So by having multiple databases, we can simply have more options here. If 1,000 users are requesting user information at the same time, instead of giving 1,000 requests to this database at the same time, why not give 333 requests to this one, then 333 to this one, and then 334 to this one, and distribute the load. And this is something that databases like Postgres can come pre-configured with, so that if you add more database pools or Postgres pools, it does this automatically for you. Or you can place your own load balancer in front of it to distribute this load. Again, load balancers is something that we'll cover in this section. And then finally, we have database types. A database can do only so much. Each database is good at its specific thing. But some databases are suited for one thing and others are suited for another. So when picking databases, you have to decide what type of characteristics or behaviors do we want out of the database. And based on that, you have to make sure you're picking the right one. And this is something that is really going to hurt your head, because there are a ton of databases out there, because there are so many ways to store data. And some of these names may sound familiar to you. We know about relational storage. We've looked at Postgres before. You might have heard of MySQL. And then there's document storage that is part of NoSQL or non-relational databases. We've learned about Redis and the key value store, but there's also things like graph databases and Neo4j or big tables. And the list just goes on and on and on. Again, don't let this overwhelm you. Most of these you're never going to touch in your career. You just want to know what the differences are, what the major players are, like Postgres and MySQL, MongoDB, Redis. But know that they're available, that when you have a specific problem, when you're creating perhaps a social network app, maybe looking at graph databases, which are really, really good for storing graph data, which is great for social connections. So, when it comes to databases, there are a lot of things to do. But just keep in mind these 6 principles of how we can improve database scaling. I'll see you in the next one. Bye-bye.